Okay, we're going to look at transformations of sinusoidal functions. So first we need to look at the sine function and some key points and information about it, and the cosine function. Okay, so the sine function looks like this. Okay, it starts at 0, sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, and sine of 360 is 0. And then it would repeat itself every 360 degrees. So the amplitude of this, remember amplitude is half the height of the whole thing. So this height is 2, so half of that is 1. The amplitude is 1. The period, which we represent with the letter t, that is 360 degrees. And the axis, the equation of the axis for this is right through the x-axis, so it's y equals 0. Now, if we're going to do some point-wise transformations in the future, we need to identify some of the key points on this. So 0, 0 is 1, 90 and 1 is another, 180 and 0 is another, 270 and negative 1, and then 360 and 0. Those are all key points on this. Now, if you're doing transformations to it and you just transform those first three, you'd get this part. And you'd probably be able to follow the pattern and be able to get this part after that. So these are the necessary ones. These are if you want to do more. Okay, the cosine graph. Well, this is what the cosine graph looks like. Same amplitude, same period, same axis. It just looks like it's been shifted. Okay, so the cosine graph starts at 1, goes to negative 1, and back up to 1 again. And here are some key points on it. So the key points are different than the key points on the sine graph. Okay, it just shifted. Now, if we're going to do some vertical transformations. So we want to think about when we're doing vertical transformations for either one of these. If you add a number to one of these functions, so say it's sine of x plus 2, what's going to happen to this? Well, if I put a plus 2 at the end, I'm taking all the old sine x values between negative 1 and 1 and adding 2 to it. So that would shift that graph up 2. Okay? If I did minus 7, it would shift it down 7. Now, how would that change the information on the side here? It doesn't change the shape, so the 360 for the period is the same. The amplitude's the same, but what it would change is the equation of the axis. So if I shifted that up 2, the axis moves from y equals 0 to y equals 2. If I shift it down 7, the axis moves to y equals negative 7. Okay? So basically, we've got this. So y equals cos of x or sine of x plus c means that y equals c is the equation of the axis. If we look at a number in front of cos of x or sine of x, so if I multiplied this by 2 or 3 or whatever, what that changes is the size of the y values. So the maximum is 1. If I multiply that by 3, the maximum is now going to be 3. And the minimum will be negative 3. So it won't shift it up or down, but what it will do is it'll change its shape. So if I put a number out in front, that's a vertical stretch, and it would change the amplitude. So if that was a 2 sine x, the amplitude would be 2. If it was 7 sine x, the amplitude would be 7. If it was a negative 7 sine x, well, the amplitude is still half the height. The amplitude is always going to be positive, and so is the period. So if it's a negative 7 in front, the negative will take this maximum and flip it down here, and take this minimum and flip it up here. So the negative will be a vertical flip, but the amplitude would still be 7. Okay? So in this case, the amplitude is the absolute value of A. Okay? So let's take a look at some examples of what this might look like. If we were to graph y equals 2 cos of x plus 1, what this is going to do is it's going to first do the stretch of 2 and then shift it up 1. If you do this in the wrong order, you're going to get the wrong graph. Okay, we need to go in order of mathematical operations, multiplication first. Okay, so you multiply by 2, and then you shift it up 1. And this is the graph that you would get. So the new amplitude is 2, and the axis is 1. So put the axis as 1, the amplitude's 2. Okay? And for this one, the axis is going to be y equals -2, okay, and the amplitude is going to be 3. But the negative means the sine graph was flipped down. Okay. Now, if we look at horizontal transformations, look at horizontal. Well, sine of kx. Well, this k inside here is a horizontal stretch. Well, actually 1 over k is. Okay, so the horizontal stretch of 1 over k. If the period is 360, the new period is going to be 360 times 1 over k, or just 360 over k. Okay, and also k would represent the number of cycles. So let's take a look at some examples of this. So sine or cos of 3x. Well, cos of 3x means that the period is going to be 360 divided by 3, which is 120. And it also means there's going to be 3 cycles between 0 and 360. Okay, so you'd have that. In this one, the new period is going to be 360 divided by 1/2, which is 720. And because there's a negative in there, it means it's going to be flipped horizontally, which means it looks like it's going to be over here. But then you can just continue the pattern over here. Okay? And this is how the information changes on those. So it just changes the period when you do that. Okay. So the horizontal translation would come in this form. So y equals sine or cos of x or theta minus d. Okay, so this is a horizontal translation of d. So the reason the minus is in there because you always go the opposite, right? So this is called a phase shift. So an example of this might be cos of x minus 90. Now, I've been mentioning that the cos graph just looks like the sine graph with a shift, okay, so a translation. Well, in fact, if you take a look at the cos graph, and it looks like this, if you continued it back, okay, it would go down to here. So that's at 90, 270, 180. So this would be at -90. Okay, so if you're shifting this thing forward 90 degrees, you're taking this point and moving it here. You're taking this point and moving it here. So if you take everything and shift it forward, it just looks like the sine graph. Okay, so by translating the cosine graph, you can get the sine graph. Okay, by putting a couple of transformations together, so both the horizontal transformations together, if you look at something like this, well, this is where you have to be a little bit careful because the inside needs to be factored in order to get the information directly. So just as when we looked at with transformations of functions, you need to factor the inside, otherwise you're not going to get the right transformations. So this means that you have a 45-degree phase shift to the right, and it has been horizontally stretched by a factor of 1/2. So the period would then be, instead of 360, it would be 180. These are not the same. This, in this form, does not mean a phase shift of 45 degrees. In order to get the phase shift for this, you would have to factor 2 out, and it would be sine of 2 times x minus 22.5, and so the phase shift would be 22.5 degrees to the right for this one. Okay, so they're not the same. So you need to have it factored. That's the key for that. Okay, so if you went to graph this, then you would say that the period is 180, so it's going to go through one full cycle in 180 degrees, and this is a nice phase shift then. Okay, so 45 is 1/4 of 180 degrees, and if we look at quarters of the sine or cosine graph, they make for nice phase shifts. They go from 0 to 1 to 0 to -1 back to 0. Okay, so 1/4 of a period phase shift makes it nice. And this is what the graph would look like. Okay, so basically what we've done is we've made the amplitude, sorry, not the amplitude, the period is 180 from the 2. Okay, and it's a sine graph shifted forward 1/4 of a period. So normally the sine would start here, go up, come down like this. So if it normally starts there, then if it came back here, if you shift it forward a quarter of a period, you would get this. Okay, so that's that one. Now, if we put them all together, okay, so here's what it's going to look like. And here's what each of those letters mean. Okay, so the absolute value of A is the amplitude, y equals c is the axis, the period t is 360 divided by k, k represents the number of cycles in 360 degrees, and d represents the phase shift. Okay, so let's do an example where we've done them all together. We're going to graph this. Well, there's a number of ways of doing this. So one way is to do a pointwise transformation. If you look at this and you look at the period is going to be 180. 135 degrees is 3/4 of 180. So as I mentioned before, if you're looking at quarters or halves or whole phase shifts, then it's nice to do. If that was 17 degrees, x plus 17, this wouldn't be so nice. And you'd probably want to use a pointwise formula. So here you're shifting it backwards 3/4 of a period. Okay? And then you're finding the amplitude, which is 3. You're shifting it up 2. So if the amplitude is 3 and it's shifted up 2, the highest is going to be 5. The lowest is going to be -1. Okay, so 2 minus 3 is -1. And it's vertically flipped. Okay? So we're going to take some information here. We're going to take this, and what I would do is graph it without the proper x and y axis. So I'll show you kind of what I did here. So what I did was I drew in an x and y axis lightly in pencil that aren't going to be my final x and y axis. I drew it in here, and then I marked off what one period would be. Okay, so that's a length of one period there. And one period is going to be 180 degrees. Okay, so half of 360. And then I marked off quarters so I get the right pieces in. Okay, so I've drawn that. So without the horizontal translation and vertical translation, I'm just using these two pieces here. The amplitude 3 means it's up and down 3 from the axis. The negative means sine opens down first and then goes up. So once I've drawn that in, and I've got the right vertical measurements on here, like this is my x-axis, then instead of moving the function back 135, I can take the y-axis and move it forward 135. And then instead of taking the function and moving it up 2, I can take the x-axis and move it down 2. Okay, it's the same effect. And then I draw in the real axes and I put in the numbers properly. And I can continue on the pattern like I did in blue here. Okay, so once you have one cycle, you can continue on that pattern. You can see what's happening. Now you might like the method of using the pointwise formula. So if you use the pointwise formula for this, you look at this, and the x coordinates are going to be multiplied by 1/2 and subtract 135. And the y coordinates are going to be multiplied by -3 and add 2, as we've done in transformations. So here's the pointwise formula. And then you take the key points that we have, okay, as we looked at before for the sine graph. They'd be different for the cosine. Okay, take those key points, plug them into that formula, and you get these points. So 1/2 times 0 minus 135 is -135. -3 times 0 plus 2 is 2. Plug them in throughout here, you get these points. Now you can check them. So the first point is going to be -135 and 2. So back here, -135 and 2. There's your first point. Then you go to the next point, which is -90 and -1. So back to -90, -1. And then -45 and 2. Okay? 0 and 5. And then 45 and 2. You plot those points, and then you fill in the graph between those, and then you can continue on the pattern. This is probably the best method to use for any of them, especially if the horizontal translation is not a quarter of a period, half a period, or 3/4 of a period, or a whole period. So it's like 13 degrees, it's going to be hard. Okay, so that's it on transformations.